The following training video will provide a product overview and installation best practices for CommScope's integrated FOSC splice closure, supporting remote PHY architectures in an HFC network. Today's always connected, streaming digital world is seeing an exponential increase in the use of bandwidth, with future demand certain to soar. There is an urgent need to transform existing HFC networks to carry more traffic and run more efficiently. So just how are multi-system operators like Comcast keeping up with the massive increase of data and growing bandwidth demand? HFC network operators are deploying several solutions to increase their available bandwidth. One of those technologies with quite a lot of buzz right now is remote PHY. Basically, the remote PHY architecture shifts part of the layer 1 physical layer equipment, that's the PHY, from the head end to the HFC node, that's the remote. A slightly more technical definition is that RPHY takes the QAM modulation-demodulation portion of the CMTS and physically separates it to a location outside of the CMTS. This function will now typically be handled directly in an HFC node in the field. The new connection between the CMTS and the remote PHY device is Ethernet as opposed to analog optical. Available gigabit Ethernet optics provide a very flexible and cost-effective transport. Although there is quite a bit more that could be said about RPHY and its benefits, I'd like to circle back to CommScope's role in supporting this architecture, specifically our integrated fiber optic splice closure, the iFOSC for remote PHY applications. The deployment of RPHY will very likely require additional fiber optic cabling pushed deeper into the traditional HFC network. Installation of new fiber, however, isn't always practical or even feasible. The solution is found in wavelength division multiplexing technology, WDM. Through DWDM, dense wave division multiplexing, several optical signals, in many cases up to 48 channels, are multiplexed onto a single optical fiber by utilizing different wavelengths. This is where CommScope's iFOSC comes into play. The foundation of an iFOSC is a FOSC 450D splice closure along with factory-assembled DWDM filter trays. The closure and trays are integrated at the factory to our customer's specifications based on the network application and WDM design. In this case, remote PHY. The remote PHY iFOSC has 7 different configurations: 4 12-channel, 2 24-channel, and 1 48-channel configuration. Specific product descriptions and part numbers can be found in our remote PHY ordering guide for Comcast.